Okay, here's two real similar logarithmic equations or applications. Population doubles in 1475 point years. So if you start at 1, you wind up at double that. Good. And I'm using this formula. E to the k times 14.75. Beautiful. And then 2 or 1 times anything doesn't change that. And then change this from exponential to log form. Beautiful. And then divide both sides by 14.75. Good, so let me do that. So it'll be ln of 2 divided by 14.75. Okay, let me do that on the calculator. That's equal to k. So k is equal to 0.04699, was it? Yep, 4699. So that's k. And they say find the growth rate. Done. Now I guess what you could do is express that as a percent. So if you move over 2, you could call it 4.699%. Oh, and then they say assume the population increases exponentially. Yeah, this would be our answer. That would be our growth rate. Now, a nice question to that would be if you started, say you started in the year 2000, this trend, then I could say, well, what would your population be in 2022? And so then what you could do is go back to your formula. Oh, did they give us enough information? They might not give us enough information. Yeah, there's not enough information because I was going to say you can go back to this formula, well, P of t equals P0 e to the kt, and you can take this k or this k and plug it in there, and if you know the time, and if you had known what the population started at, you could figure out what the population would end at. Maybe the next question will be like that. Okay, artifact discovered certain site. It has 62% of the carbon-14 it originally contained. What's the approximate age of the artifact? Oh, and they say carbon-14 decays at this rate, or that. So this is percent, so this would be a decimal. Okay, so here's our formula. P of t equals P0 e to the kt. And they say it has 62% of the carbon stuff it originally contained. So similar to the last question where it says the population doubles. So if it doubles, you start, say, at 1 and you end at 2. Or you could have started at 10 and end at 20. With this one, they give you a percentage. So what you can say is, well, I started at 100%, and now I only have 62% of that. E to the 0.00, is that 3 zeros? 1, 2 times t. And there's a exponential equation I can solve. So I divide both sides by 100. So 0.62 equals e to the 0.00012t. And then change to log form. Log base e at 0.02 equals 0.00012t. And then divide both sides by that. So you get ln of 0.02 divided by 0.00012 is equal to t. Let me do that on my calculator. Okay, 2 little things I messed up. This is supposed to be 62, not 02. Then the other thing I messed up is this. So the decay rate is that, but to tell me that it's decaying, this number here would mean that it goes up. If I put a negative in front of there, it means it's going down. And so that k value has to be negative 0.00. So this is negative, this is negative, this is negative. So when you do that, your date is 3983.6, 3983.6, or let's call it 3983 an 80. Oh, an 80, sorry, an 84. That's funny. I'm sick, eh? And I think that maybe my sickness is clouding my head. It's my excuse anyway. Hopefully that helps you with those two questions.